Harish Gupta from Habitat and Skins. He will talk about various effects of facade envelope failure on the internal environment. Mr. Harish Gupta is an architect and civil engineer with more than 30 years of experience in architecture and facade. His company, Habitat and Skins, a design studio in Mumbai, conceptualized by two people from different backgrounds, bring to the foray the two important side of projects businesses: quality in design and efficiency in resources management. Let's welcome Mr. Rishikesh.
Very little about my company. So basically, we are into facades since 95, 96, when I actually first joined Firoz Kodianawala. At that time, we were designing buildings in Bandra Kurla complex, and those were the first buildings, one of the first buildings in the country to come up with the glass facade. So ever since that time, a lot of buildings have now been designed with glass facade, and they are continuing to get designed with glass facade. So over the years, we have shifted our focus primarily to facades and the facade design, the facade engineering, facade execution, which is under facade PMC and facade audits. So what we have realized is that there is a lot of care that needs to be taken for the facade execution. Otherwise, it leads to a lot of problems. We have come across a lot of problems with the glass buildings, and they are not just because the design is wrong, but it's basically the implementation and the fabrication work that is involved requires very high accuracy and requires very voted or very pointed supervision. So we have just so I'll get on to the presentation, which is various effects of facade failure on internal environment.
Yeah, we can see the screen, sir.
Yeah, it's just that these small icons are coming in the way. That's all.
It's visible for us.
Yeah. So building facades are a combination of transparent and opaque material. Basically, you have the cladding material and you have the glass material. That's what the modern facades are built of. And most probably, what you'll find is that the entire facade system wraps around an RCC skeleton. Okay, so we are not doing block work the way we used to do in the olden days, though there are certain hybrid buildings where you have certain civil works combined with certain glass, certain facade elements. But then most of the buildings you will find, they are completely wrapped around with the facades. Now, what are the basic parameters of facade performance? Because these facades are provided in a manner that they are supposed to give you certain performance. Apart from the aesthetic appeals, they are supposed to control the heat, the amount of light that comes in, the air, which is the outside air should not be coming in, or the inside air should not be leaking out, the wind. Now, air is whatever is the ambient, but the wind is during when you have a storm or very high speed winds coming. So that's a different parameter altogether. Rain, dust, and snow. Now, the facades that do not perform against these elements fail, and this is what we are going to discuss. And then what happens is your interior space, which is a controlled environment, that gets disrupted. So what are the facade materials made of? Primarily, I'm just talking about primary materials because otherwise we can go on a lot of elaborate discussion. So glass forms the transparent material, which essentially nowadays it comes with a particular coating, and these coatings are supposed to give a certain performance. They will allow a certain percentage of the ambient light to come in. So if it is a warm climate, it will control the light in such a way that less light and heat comes in. And if it is, let's say, a cold country, it will allow more light to come in. So depending on which environment you are situated in, you select the glass. So we don't just select the glass for aesthetics. We select the glass for its performance. And that's why they are called performance glasses. Cladding is the opaque material which integrates with the facade system where light is not desired to reach the internal environment. And these can be any kind of solid metal sheets, ceramic tiles, natural stones, basically any kind of material can be put on facade, GRC, anything that you can dream of, even bricks can be integrated into facade for that matter. So it is just a method of how you implement and how you integrate this in a manner where it not only gives you an aesthetic appearance, but it also controls your internal environment. Now, this entire system is mounted on aluminum frames, which basically supports the glass and the opaque materials. Okay. And because you need to mount it onto the RCC structure. And because these are made of panels, so there are vertical and horizontal joints which run through the entire system. And these joints will have the silicon or the gaskets. Now the gaskets and silicons basically they form the seal in these joints so that the outside environment does not get inside, and also it allows for the movement of the facade panels. And then this whole thing is mounted with the help of brackets and anchors onto the RCC structure, because that's what holds the facade. So these are basically the 5 materials that you can associate the facade with. Now, how does it fail? Now, this is where we are talking about, because once the facade fails, that's when it stops performing. It allows the outside environment to come in. It leaks the inside air to the outside. So how does it fail actually? So the glass in the building, normally nowadays they are double glass units. Previously, when we started facade building, they were all single glass. But now virtually every building is double glass, and in some places where the high performance is required, it is triple glazed also. And it fails if the seal between the glasses, which is over here, which you find. So this glasses have an air gap, and then there is a seal which goes all around the glass. So that's when it fails. So it allows the water to come in, and then you'll find moisture coming in or the coating getting damaged. So that is one way of failure. So the coating, when it gets damaged, it will cause some kind of a rainbow effect. You will not have the performance of the glass. Also, it will not perform in terms of stopping the heat properly. It will not perform in terms of allowing the correct gradient of light inside. And the other failure happens in glass is when it is either improper fixed or the quality of the glass process is not good. So when it starts to shatter, you'll find that a lot of buildings complain of glasses shattering. So the primary reason is either the quality is bad or the fixing is improper. When the fixing is improper, the glass comes under a lot of stress, and these glasses, the moment they are stressed, they will shatter. The other material is cladding material, which I mentioned, that can basically have any kind of cladding materials. Now, even that forms the part of the building envelope, and the failure of that material will also cause the facade to not perform. So these generally where we have dead walls. This is where we have the cladding, and or where the light is not required to come in. And this interfaces with the structure and the glass that forms part of the facade. So basically, wherever you have the glass, you will find that the termination is in some kind of a facade material, because the aluminum sheets or any kind of a sheet material, they are flexible enough to be bent, and then they form the joinery between your RCC and the glass material. So like this example of coping. Coping is at the top of the parapet wall. So once the glass finishes the termination, then you need to have the whole thing as a coping so that the water does not enter inside between the glass facade and the walls. So wherever you have these interfaces, the end terminations, you will have some kind of opaque material which will interface with your building so that the outside environment is sealed. Plus, you have the dead wall areas where you can do virtually any kind of opaque facade, whether it is aluminum sheets or ACP or tiles or stones, which I had mentioned earlier. Now, this is what happens when your interfaces fail. So basically, the water starts to come in from the sides, and the whole interior environment gets disrupted. And what happens is these are very costly to rectify, because in a facade, you cannot just remove an element and refix it. So a lot of care has to be taken at the time of facade implementation. The third element is the framework that holds these opaque materials and the glass together. So you need aluminum frames because they are lightweight. Secondly, you can extrude it to any design that you want. MS has a limitation. You cannot extrude it very intricately, but in aluminium, you can intricately extrude it. So whatever design you need from the frames, that design can be made, and they can be extruded in an extrusion company. And then we attach the glass and the gaskets and the silicon, and we make the entire frames, and this is joined, and then the whole thing is called as a facade unit. Now, the failures basically happen when these joints are not done properly or the design is not proper. So you'll find that either they are not sealed properly, or there is a movement in the facade which is unaccounted for in the design, or there is a movement at the time of installation which has caused the joints to open up. And this is what happens then. Then the joints open up, the seals get separated. That is the gasket seals get separated, and then it allows the wind and the air to come in. So you find a lot of water during the rainy season, especially in a city like Mumbai. You'll find a lot of rain water coming in. The fourth is the gasket silicon from and that's the most important, the gasket and the silicon, because that's what actually seals your facade. The glass and the opaque material, they are hard materials, they are brittle materials. But the gasket and silicon are the flexible materials. So they basically form the joints between these rigid materials. The gaskets allow the individual facade components to move as per building movement, the expansion and contraction of the facade unit as per outside temperature, at the same time maintaining a water and airtight assembly. While gasket forms flexible seals of the facade, the silicon on the other hand forms the fixed sealing of the facade, where gasket provisions are not desired. Silicons are also strong enough to hold the facade material, and these silicons are called structural silicons. So they hold the glass onto the aluminum frames. Now, failure of gaskets and silicon will lead to water and air passage in and out of the interior environment. So you have to take a lot of care during the installation and fabrication to ensure that the gaskets are in the correct place and the silicon seals are done properly. And you need to do a regular audit at every stage of the implementation and fabrication, because that's the only way you will improve on your implementation. So this is how some of the failures are, where you find the gaskets are twisted or they are short, the alignment of the panels has gone skewed. Now, once all this happens, your facade starts to fail. These are pictures taken from the outside of the facade. Then last one is the brackets and the fasteners, which actually holds the entire assembly. And you need to design that properly, because that is the strength material. If that fails, your facade can fall off. So there's a lot of attention paid to the bracket designs and the anchors, which goes on to the RCC structure. Even the RCC structure health has to be good. Like if you have a M40 concrete or a M50 concrete, then your brackets are designed as per that. So facades that move due to improper bracket and fastener will cause the joints to open up and allow the external environment to enter the interior controlled environment. So the movements are not desired, only the allowable movements due to expansion and contraction. But otherwise, the movements are not allowed in the facade. And of course, there are certain earthquake movements also for which the facades are designed. They are also allowed. But beyond whatever is allowable, anything that in a bracket failure will make the facade also fail. So this is how some of the failures, this is just some of the examples, how the brackets fail and then the whole facade starts to fall. Even the glasses will break if there is a movement which is putting stress on the glass. So you find a lot of glasses shatter because the system's designs are lacking in certain aspects. So the last, I'm stressing a little point on the facade audit, why it is important. Facade audit by a third party. Always you have to do a third party, because whoever is party to the contract cannot very honestly conduct a facade audit. So a third party is always the best. So you get the person on board right when the project is starting, so that regular audits can be done and you can keep improving the quality as you go along this. So reports can be generated and according to that, you can improve the facade. Now, facade forensic is when the facade has failed. So audit is when you are actually making the project, and facade forensic is when something has gone wrong and you try to find out what is the problem and why things have gone wrong and how to rectify. So forensic helps you in getting the correct solution to the problems that have occurred. So both are very important. Of course, audit comes first. If the audit is done properly, you will possibly not need the forensics. So this is in a nutshell a little about the failures of the facade, how it affects the environment. Thank you.